After my last video, I wanted to talk about Aether some more because there were a lot of questions about special relativity and its effects on photons. And I also wanted to revisit the Michelson-Morley null result. There is no ether drag on photons because the photons are made of ether. Now, in the de Broglie model of the photon, which I favor, the photons are made entirely of quantum fluctuations. There's a rotating electromagnetic field of the photon, which is identical to a field made from a rotating dipole. A dipole that only exists for half of a wavelength, where the rotation is 180 degrees and exists at the Planck energy. And so in the de Broglie model, you have a series of dipoles in the center that alternately rotate, creating a field around them, which is also alternately rotating and oscillating electromagnetic fields in the transverse direction, dependent on the plane of rotation of the dipoles themselves. And one of the keys of this when it comes to relativity is each individual dipole is not moving relative to the ether. It's effectively stationary. And then each one successively jumps out in front of the other one, allowing the energy to propagate. So their velocity relative to the ether is zero. Hence, there's no special relativistic effects on photons because the matter within the photons isn't moving. That's why photons supposedly move at the speed of light, because only the energy is moving at the speed of light. So it doesn't conflict with the special relativistic issue that matter can't move at the speed of light, because there's no matter moving at the speed of light. That's how photons work the way they are. And there's no ether drag on photons because they're rotating in the rest frame of the ether. And yes, I said rest frame of the ether. If you consider the way the ether rotates, it can't have an infinite number of rest frames. There's going to be some frame of reference where it has average rotation, and that's going to be its rest frame, which is another problem with special relativity, assuming there's no rest frame. And one of the interesting things, because the photon energy always travels in the ether rest frame, is that when a photon leaves the source, it immediately Doppler shifts. The energy does, based on whatever the relative velocity is between the source and the rest frame. And then when it hits the detector, it Doppler shifts again. And if the source and detector are moving together, you would have no idea that the light is being Doppler shifted to the ether rest frame in between. But it is. So looking back at the Michelson-Morley experiment, the source and detectors are all traveling relative to the ether at the same velocity. There isn't a difference in velocity. There also isn't a difference in distance between the sources and detectors. Even when they're rotated, there's no change in distance. And the velocity of the photon is not dependent with distance either. You get the same velocity in any direction. And that's because the photon velocity is dependent on permittivity and permeability. And whatever the permeability and permittivity and permeability are at one point, a photon has the same effect on it no matter what direction it takes through that point. So this means that we should not expect any type of ether drag measurement with the Michelson-Morley experiment. The issue was that we had no clue back then how the photon worked. What was the photon made of? How did it propagate? We didn't even know what the photon field was in the 1880s. We didn't know there were electron-positron quantum fluctuations until the 1930s. And no one apparently put the puzzle pieces together in the right order to make everything fit. Although De Broglie must have come close, but his model just never caught hold, unfortunately. Now we do have in general relativity, the permittivity and permeability do change in space relative to the matter distribution. If you have stars, galaxies at whatever distance, they change the local permittivity and permeability, which is something Einstein was working on and unfortunately abandoned, because he abandoned the correct path to go on the wrong one. And in special relativity, when a body moves, the apparent permittivity and permeability increases. And this is due to an increase in the van der Waals torque, which regulates the permittivity and permeability. Because when there's matter stationary, it increases the van der Waals torque, which increases the permittivity and permeability and decreases speed of light and gives us variable speed of light relativity. But when matter moves, matter increases an additional increase in van der Waals torque because of its own motion relative to the ether. And that increases the permittivity and permeability, which decreases wavelengths and slows clock rates. So there's still special relativistic effects going on with matter that's in motion relative to the ether. Just there's no special relativistic effects on photons itself because only energy is moving. And the photons aren't affected because they're made of the ether, and the ether's not moving relative to the ether. So anyway, I hope you found this interesting and answered some questions that popped up in my recent video. And so please like it if you liked it, and share it with your friends who need to understand photons and special relativity better. And please subscribe to see more of my videos. And if you'd like to read about my research on quantum field theory, and this in particular I talk about a lot in my book, The Zero Point Universe, and talk about mistakes that are made by ignoring the quantum ether in my book, The 100 Greatest Lies in Physics. And as always, thanks to my Patreon, PayPal, and Super Thanks supporters. You're a big help. And thanks to everyone for watching.